Thank you all so much for having me here tonight. I'm very happy to be presenting. This is the ABCs of BDCs. We're talking big data clusters for beginners. So this is basically introductory course to SQL Server Big Data Clusters, which was a new feature in SQL Server 2019, if you weren't already familiar. And we're just going to basically talk a little bit about architecturally how they work, talk a little bit about how to set them up. Both of those topics can be entire presentations on their own, but the real meat of this presentation is I have some demos just to kind of show what can you do with a big data cluster, because I feel for an introductory session, it's far more interesting to show what can you actually do as opposed to sit and just talk academically about them in a slide deck for a while. So just to briefly introduce myself, my name is Pusateri. I've been working with SQL Server and the Microsoft Data Platform for about 15, 16 years now. I am based in Chicago, so I helped run the user groups in Chicago. I don't have quite as much of an active role with the user group anymore. I do help run the SQL Saturday, or the event that was formerly known as SQL Saturday in Chicago. Been doing that for 8-9 years. And I also am involved with the community. Probably the best thing you'll find on this slide is my contact information. If you have any questions after this session that we aren't able to address, or if you're watching this recording later and you'd like to ask me something, feel free to reach out to me on Twitter or via email. I will have this slide up again at the end. And also I have a link at the end I'll show you that has all the slides from this presentation and all of the demo notebooks that we go through. So you can all download it. It's all on GitHub, and Harry has that already. So hopefully it's going to get posted to the website for this meeting if it hasn't been already. So just to start off, what is a SQL Server Big Data Cluster? And I said it's a new feature in SQL Server 2019, and the idea was it builds on what SQL Server already offers and helps you integrate big data with your relational data that's in SQL Server. So data that's in HDFS, you can manipulate it with Spark. It also heavily leverages the Polybase enhancements that are present in 2019. Polybase itself has been around for a couple versions of SQL Server at this point, and we'll go through what that is briefly. But there's some enhancements in 2019 that they really take advantage of in a big data cluster, and you get this deep integration with Apache Spark, and you can access data through Spark, you can access data through Virtualized Data through Polybase, and you can have relational data all in one place, and you can query all across it pretty seamlessly. Now, to talk architecturally about what is a big data cluster here, and I do have a couple slides, and this is a slide actually, if anyone saw this presentation or Buck Woody's presentation at past Summit, this is actually a slide from Buck's session that I'm using with permission, so you can go tattle on me if you want, but Buck's cool with it. He has enough reason to be upset at me anyway, usually. So this is kind of going over the architecture of a big data cluster, just showing we have these big black boxes here. These are the actual nodes, servers, either physical or virtual, though they'll likely be virtual. And what I'm working with today, what I'll show you is indeed virtual. So we have server nodes. We have Kubernetes, right? Big data clusters run in Kubernetes. It's if you're not familiar with that, that is a quasi-virtualization platform, except instead of virtualizing the entire machine like one would do with a virtual machine, this is actually virtualizing more of a process, basically. So you can have processes and applications running virtualized within Kubernetes. So there's a whole bunch of those that get virtualized to build a big data cluster. There's a lot of moving parts to one, and you'll see some on the next slides. But Kubernetes is here, and then we have containers and pods, which is how Kubernetes works with workloads. Essentially, it manages what's going on in what it calls pods. Pods contain containers, which are like individual applications. So we have all of this being managed by Kubernetes. We have storage off to the right there in volumes, and you'll notice how the volumes are separate from everything. That's because storage needs to be persisted. So while you can store things in a container, if that container dies or is otherwise removed, the storage would disappear with it. That's not good, right? Especially when we're talking about data. So we have these storage volumes off to the side. We connect to the storage that way, and if containers disappear or get recreated or die for whatever reason, the storage and what they're working with is persisted. So that's why that's off to the side. Kubernetes is managed through through a tool called kubectl or kubectl. You might have heard of it. It's a utility you need to manage any Kubernetes deployment, and indeed we need it to manage a SQL Server big data cluster as well. And we'll talk through that in a slide or two. And additionally, there's another application you'll need called AZ Data, which is a CLI for managing the big data cluster itself. Now to take a look at the actual big data cluster components here, this is still using the blue and the gray squares to represent pods and containers. But you can see we have a whole bunch of moving parts here. And SQL Server itself is one of those parts. Let me pull up my pointer here. Oops, wrong slide, hang on. So we have the SQL Server master instance up in the upper right corner there. That is actually the main endpoint you connect to for a big data cluster, and it is an instance of SQL Server. It's running in Linux, in Kubernetes, but it is still a SQL Server instance, and you can do most anything with it that you can do with a normal SQL Server instance that's not part of a big data cluster. The big data cluster also has what it calls a compute instance, which is a kind of a worker node that is also SQL Server, but you don't directly connect to that. So you're issuing commands and doing all kinds of stuff with the master instance. The master instance is, in most cases, telling the compute instance to, hey, go ahead and do what you're actually doing, whether it be a query or data load, something like that. The big data cluster provides what's called a data pool. We'll talk about that on the next slide. It also has, like I said, HDFS and Spark integration. So there are nodes running HDFS, Hadoop distributed file system, where you have your big data files, whether you have CSV or Parquet or something like that, handling the storage for that. And there are nodes that run Spark. And all these things can communicate internally. Additionally, you can put other applications in a big data cluster if you want, and access those via a proxy. And then on the right side of this box, we have kind of the administration workers, should we say. So there's Kibana and Grafana, which you can access through a proxy, which handle like logging and error management and whatnot from all the different parts of the big data cluster. There's a control service that controls it all, and there's a configuration store that manages the configuration of the cluster. So as you can see, there's a lot of moving parts in a big data cluster. It is not a simple thing to deploy. I mean, it is, but it's all deployed by script. It is not a single unit like SQL Server would be. So to show this kind of a different way, I have this slide here now, and this is looking again at the components of the big data cluster. So we have the nodes on the bottom. We have our Kubernetes cluster that's sitting within it, managed by kubectl. And then within the big data cluster itself, we have components of the big data cluster. We have a master instance, we have a SQL data pool, and a storage pool, a compute pool, and an application pool, and we'll go through those in just a minute. There's also web services that you can use to manage and access data in the cluster. Azure Data Studio plays a big part. It's a great way to deploy a big data cluster as well as to query it and work with it. And then we have that AZ Data tool I told you about, which actually manages the cluster itself from the client side. So to talk a little bit about these before we get into the demos, I mentioned there's a master instance. This is pretty much a regular SQL Server instance. It's again on Linux on Kubernetes. It's your main connection endpoint. So you would connect to this with Azure Data Studio or SQL Server Management Studio, just like you would connect to any other SQL Server instance. If you wanted to do something like restore a SQL Server database into a big data cluster, you would restore it to the master instance. You can put databases on the master instance, though typically you'll be dealing with remote data that's either in HDFS or on remote sources through Polybase, but you can put databases on the master instance if you choose. This also handles all the metadata for the big data cluster. So there's metadata dealing with HDFS, there's metadata for external tables, there's metadata for sharding if you're using the storage pool, things like that. So metadata and user databases that you're working with is basically what ends up in the master instance, and it manages all this communication for you. External tables play a big part in big data clusters. Like I mentioned, we're dealing with Polybase, which is how data virtualization occurs in a big data cluster. And Polybase itself is not a big data cluster feature. As I said, Polybase has been around since SQL Server, 2014, 2016, I believe. So this is not BDC specific, but this allows you to query other data sources like remote SQL servers, Oracle, MongoDB, data in HDFS, etc., like it was local, right? So you don't have to perform ETL anymore. You can access this data in its native format pretty seamlessly through the database, whether it's in a CSV file, a Parquet file, or in any of those other platforms like I mentioned. You can query these tables like any other table, but they are read-only, so data that you're accessing via an external table, you can't modify, you can't insert, update, or delete into it, you can't create indexes, but you can create statistics. These queries, if you query an external table, if you've never done this before, they are real-time queries, so when you query it, SQL Server will go contact whatever this data source is and query that data source. There's no caching going on in SQL Server. Polybase works very hard to push as much of the query down to the source system as possible. So if you're trying to, write a query with a where statement and filter millions of rows, it's going to try very hard to push that filtering down to where SQL Server doesn't have to worry about it. The old parallel of querying a remote server where, I'm querying 1 million rows and filtering out 100,000 of them, and SQL Server actually has to read 1 million rows back from the remote server and do the filtering locally. That's pretty bad. So Polybase tries to avoid that and usually does. Queries will hit the source system to do this. Only the sources in Polybase that are supported by Linux will work here because, again, the master instance is SQL Server running on Linux. Now, that being said, I believe most of the Polybase sources these days are supported in Linux. I can only, off the top of my head, I believe ODBC is not supported in Linux, though that may have changed as well. But you do have the limitation of it does not support everything that it does in Windows because nothing about the big data cluster is actually running in Windows. It's all running on Linux. Next, we have the data pool, and this is actually really cool. This is a pool of SQL Server instances that are part of the big data cluster that provide storage and compute, and they're all managed via the master instance, and we'll see this in a demo too. But if you have essentially a pool of these servers and you create a table in the data pool, all the data in that table is sharded across the servers, distributed. So, if you have 4 servers in your pool and 40 million rows, each server is going to get about 10 million rows. And when you query your data pool, those queries then spread across these servers and you get your data back more quickly with better performance. This is a great way to stage the results of like commonly run analytical queries or things that are slower, and then you can run this against your data pool and it should perform quite well. After that, we have the storage pool. And this is the HDFS end of the big data cluster. So it actually does provide an HDFS storage cluster within the big data cluster. You get persistent storage for your structured and your semi-structured data, your CSV files, your Parquet files, your text files, whatever have you. And you can access this data either through the SQL Server master instance. You can query it as an external table through Polybase, or everything in the storage pool is also queryable through Spark. If you like working with Apache Spark, or you want to learn, this is a great way to do it because you can actually query all this data 2 different ways, essentially, and access it that way. So that's a rundown of the major components we're going to talk about here through our demos. Creating a big data cluster. So creating a big data cluster is, like I said, it could be an entire presentation on its own. Fortunately, Microsoft makes it pretty easy to do so if you haven't already, or if you want to see how to do it here. So I'm actually going to pop open Azure Data Studio. And if you're looking to create a big data cluster, you can go here and say new deployment, and it'll actually pull up a wizard where you can deploy different things, one of which is a SQL Server big data cluster. So this is actually a wizard. You can sit and you can run and say, okay, I want to deploy SQL Server 2019 big data cluster in an Azure Kubernetes service cluster. That's how I do it, at least. I run everything here. Everything you see tonight will be running on Azure Kubernetes service, except the rules. It will make sure you have the required software installed. So as I mentioned, you have to have kubectl installed locally, and you have to have AZ data, which is listed here as Azure CLI, installed locally to deploy a big data cluster, even if you're deploying it to the cloud. And that was kind of, didn't make a whole lot of sense to me at first, because I'm very used to, when I want to deploy something in the cloud, in Azure and AWS, I say, hey, I want to deploy it here. I don't need anything locally other than whatever I might need to connect to that resource. Well, with a big data cluster, not the case. It's actually deploying the big data cluster from your local machine. Even though it's deploying it in the cloud, you still need these tools available locally to do that. So you have to have kubectl and AZ data installed, which I do, so it'll let you go to the next step. Pick what kind of deployment you want. Usually I use the test deployment that has fewer nodes in it, right? I'm trying to do something for demonstration purposes. You then go and you plug in your Azure subscription ID and give it a resource name and a location and whatnot. Fill in a couple more things. What this wizard will do when it's all done here, and I'm going to cancel out, is it will spit you back a Python notebook, actually, which is what I have here. And then you just say run all, and it will actually go through and deploy the entire big data cluster for you. This is my favorite way to deploy a big data cluster. You can certainly do it with scripts on your own if you want, but I think this is pretty darn simple. I am not going to deploy it for you right now because this takes about 15 to 20 minutes to do, and I don't think you want to sit here and watch that happen. So much like on a cooking show, I already have a big data cluster running that we can work with, but I just want to show you this is how you can deploy it. Azure Data Studio makes this nice and simple, and you end up with a notebook that you can run over and over again whenever you want to deploy a big data cluster. All right, so now that I've done that, talked about creating, let's actually go to the meat of the demos, which are querying and just using a big data cluster. So I'm going to escape out of here so you don't have to look at that white background the whole time. And I hope I have my zoomed in enough on this. If this is difficult to read, please speak up and tell me I need to zoom in more or whatnot. But I've zoomed in a couple times already. I think this is hopefully visible. So just to walk you around the big data cluster environment here, like I said, I'm connected to a big data cluster right now in Azure Data Studio. It looks pretty much like a regular database would, I realize. I don't think I can use zoom it here. I'm going to try and hopefully I don't break something. No, it doesn't work. Okay, sorry. Looks like a SQL Server database normally would, except we have this HDFS node here at the bottom, right? So this is actually the storage pool for HDFS. So you can put things in here, and this will be in the Hadoop file system that you can access through Spark or through SQL Server. I have some demo files here. We'll talk about that in a little bit. If you want to manage your big data cluster or see what you can see, you can right-click it and hit Manage, just like any other SQL Server database. It'll pull up properties of the database and the management page. I realize this probably looks mostly like any other SQL Server instance, but we have this third node down here for SQL Server Big Data Cluster. This will tell us much more about our big data cluster. It will give you all the endpoints for it. Like I mentioned, there was a whole bunch of services. If we went back to the slide deck talking about the parts of the BDC, these are all the endpoints for those locations that I've spun up. And again, I've deployed this in Azure and Azure Kubernetes service. So you can see there's the master instance, which is what I'm connected to right now. There's management, there's metrics, there's HDFS locations, there's a cluster management service, an application proxy. So you have all these different endpoints you can connect to, though most of the time you'll probably just be connecting to the SQL Server master instance on the front end.
Bob,
Yes.
quick question.
Sure.
So, when you were on that previous menu to create, there was resource group there question, and there is do you have to pre-create resource group, VNet
You do
grouping? All
not.
you do not. Okay.
You specify the name of the resource group, and if you're
Mhm.
using this notebook, it will go ahead and it will
Oh,
create the resource group and create all the. And yeah, you're right. There's a virtual network. There's lots
yeah,
of storage nodes.
yeah.
There's multiple containers and whatnot. All that is spun up. Literally nothing I have to do other than run this notebook, and it will set the whole shebang up for you.
Awesome, great.
Yeah, that's pretty nice. And then to tear it down, I just usually delete the resource group.
Yeah,
That makes it nice and easy, and that'll get rid of everything.
perfect. Thank
Any
you.
other questions or? Not yet. Okay. So the other thing you can see here is if we go to the bottom of this, we'll see at the very bottom there's SQL Server Big Data Clusters. You can also connect and manage the cluster this way. If I double click on this and say manage, it will bring me to more or less the same page that we were just looking at. This will give me a bit more detail. It'll show you all of the containers and their statuses. So like looking at SQL Server here, there's a master node that's running, there's compute nodes, there's 2 data nodes, there's 2 storage nodes, and then you can see the same thing for Spark. So you can see the status of all these if you want to drill in and really see what that looks like. That's probably the big advantage of using the menu at the bottom here is it'll show you all that. It's a little easier at least. So with that, kind of walked you around how to set one up, what it looks like to connect to one and manage one. So at this point, I think we're good to actually start doing a little bit of demo work in it here. So I have some data, and this is airline data that I managed to get from kaggle.com. And again, if you were to go to the GitHub page I've set up, I have links to where you can download this all to try for yourself. I can't really distribute that data per the agreement for Kaggle, but I do point you to the page where you can download it yourself. It's just a CSV file. So I have uploaded this into HDFS already. You'll see I have a airlines folder here, a CSV folder underneath that, and I just have a file called airlines.csv. It is literally just a CSV file. If you right click on a folder in the HDFS section here in Azure Data Studio, you get a menu that shows up. You get an option to actually virtualize data from CSV files, and this will actually do a wizard. This will show you a wizard to virtualize this data to do what I'm going to do here in a SQL script. Which actually reminds me, there is a plugin you want for Azure Data Studio if you're going to be working with big data clusters, and it is a plugin called Data Virtualization. And basically, this plugin gives you the wizard that menu will show you. So if you like working with the wizards, definitely install the Data Virtualization plugin. Sorry, I didn't mention that before. But anyway, so you have an option to virtualize the data. You can preview the data, and I'll click on this just to show you. This will literally just open up a, did it disconnect? Hang on, okay. Give me 1 second here. It probably fell asleep because I had this sitting here for a while. See, I knew we'd run into some kind of problem here. Node command call without any node pass. Give me 1 second. Let me disconnect and reconnect from this. Never a dull moment when you're doing live demos. There we go. All right. So literally this will just pull back the CSV file, and you can see I have a CSV file here that has a bunch of information about airlines. So it's got an ID for them, it's got the name of the airline, its alias, its airline code, the country it's from, whether it's an active or a defunct airline, etc. So just some decent data to play around with a little bit. So I am going to first of all, take this CSV file and just create an external table for it in our big data cluster. So to start off with, I need a database to do this in. I do have a couple databases in the big data cluster already. These are the ones it creates by default. So there's 3 here. There's DW configuration, diagnostics, and Q. These are effectively system databases for the big data cluster, but they're not labeled as a system database. So don't mess with those. But if you want to do work, create another one. So I'm just going to create a database here called airlines data. And I'm going to create a schema within that database called CSV because I like to use schema names to kind of help recognize where that data is coming from. So this first schema here for CSV is going to be just coming from a CSV file. Now to access this CSV file as an external table, if you haven't worked with Polybase before, you need to do a couple things ahead of time. You need to create a data source, which points to where you can find this data at. We're looking in HDFS, so there's actually a URI for that. It's SQL HDFS / controller service / default. So that is how you point the master instance of SQL Server to the CSV, to the HDFS store. So we're going to create that external data source. We then have to define a file format because we're reading a file. SQL Server needs to know what this format is. So we're using a CSV file. We're creating a format for CSV, which basically defines a field terminator as a comma, delimiter as quotes, and it says the first row is row number 2 because the first row of this file has the column names in it, so we don't want to count that as data. Now that we've created our data source and our format, we actually go ahead and create the external table. And again, if you haven't done this before, this is effectively a create table statement, but it's external table. So we're defining a table, its columns and its data types, but we're saying read in this file and act like it's a table. So I'm creating the external table for that. This happens really quickly. It is not checking the contents of the file. It is literally just creating the table in metadata. And if I were to refresh up here, we'll see we now have an airlines data database. And in tables, we have csv.airlines, and it's marked as an external table. So I've created my external table pointing to this file. And now what I can do is I can go ahead and query the table. And it's going to blow up. And if you've worked with Polybase before, you've probably seen an error like this at some point when you've been trying to query a external data source. This can be a couple things. This can be file encoding. Maybe the file is UTF-8 with a byte order mark, and it was expecting to not have a byte order mark, something along those lines. It can be poor data type choices, which is actually what this is. This is an error that I kind of set up on purpose to show you how we can manage it. So in order to be able to query this file through an external table, we might have to check our data and make sure that it's conforming to the data types that we set, which, as I said, SQL Server isn't doing. So here in this next notebook, which this is a SQL notebook, this is now a PySpark notebook, which I need to connect to the big data cluster instance so it will work. In this notebook, I'm actually going to just kind of profile the data and see what we have going on here. So I'm going to run a little bit of Spark just to connect to the file and pull back the first 10 rows of the data. And this will actually generate this first cell in the notebook. It'll actually generate for you automatically if you want to. You could right click on the file and say analyze a notebook, and it would literally create a notebook with just this first cell in it so that you can see the data. And it takes about a minute to start up the first time because it's actually starting a Spark process. So we gotta hang on here just a moment longer while it does this. But once this is complete, there we go. It's going to give us just the first 10 rows of the file. So it's reading in that CSV file through Spark. Now that we're in Spark, we have what's called a data frame connected, and that's what I've done here. This last line here is df.show, or show me the first 10 lines of the data frame. Spark has a command called print schema you can run on a data frame. And what this will show you is that data types in Spark are different from data types in SQL Server. For this particular data frame, we have an airline ID, which is an integer, but then everything else is strings. There is no varchar, end varchar, and there's no length on string types, at least that we see exposed here. So everything is a nullable string, except for the ID, which is a nullable integer. This unfortunately doesn't help us because we need to figure out what's wrong with my data type selection. So what I'm going to do is I like to use a library called pandas, and pandas has its own type of data frame. So I have to import the pandas library and create a pandas data frame. But now that I do that, I can run a command called info in pandas, and it will kind of show me a bit more information about our data set. It'll show pandas has int32 an object instead of integer and string. That still doesn't help me. But what I can do is run this command here, and this will very quickly go through all the data in that file and show me the maximum length of each column. So I'm running this. This is showing me that the name column has a maximum length of 81. But what's breaking it actually is the country column, which has a maximum length of 37. And if we go back to my SQL, I had it defined as 10. So poor data typing can result in errors. What I'm going to do is drop this external table and recreate it with a proper column length. And if I query the table now it works fine. So what I'm now doing is querying this external table. So behind the scenes, it's reading the CSV file, but it's treating this just like a table in SQL Server. right? And here's the first 100 rows, which is what I'm pulling back. Now, as I mentioned, these are external tables are read-only. So if I tried to create an index, I'd get an error that indexes are not supported with external tables. Similarly, if I tried to update something, I'd get an error that DML operations are not supported. But if I wanted to run any kind of select or any kind of join, which we'll see in a little bit, I can select, I can filter. So I have select for the airlines that are active and from Belgium in this data. So I have here, and I have 6 airlines that it says are based in Belgium and active, and one of them is Thomas Cook Airlines, and I believe they went bankrupt a couple of years ago, unless they're back now. So maybe this data set isn't the most up to date either, but it works great for demo purposes. So this is kind of just showing external tables and how you can access data in HDFS in your big data cluster. Before we move on to the next demo, are there any questions I can answer to this point? I don't see any in the chat, so I'm guessing I'm either explaining this really well or, oh, we got one?
Actually, I do have a question. Just
Okay.
want to clarify something. So the Azure Kubernetes services itself is actually free. Am I correct?
It might be that the Kubernetes service is free, but
Yeah.
the actual containers running in it are not.
Right.
I can assure you of that. Yes.
Right. Yes. Yes. So the VM itself. So I was just wondering, in case our attendees and the people wants to try deploying to Azure Kubernetes services using their, because Azure gives you 30-day free trial, right? You create a.
They do. I've never tried doing this under the free trial, so I don't know if all the resources are included in that.
Gotcha. Okay.
I can assure you that what I'm doing here is not free, to be completely honest.
Yeah.
But yeah, I think you're right. I think the actual AKS management part does not charge because you're paying for the resources that you're managing. Right. Is my understanding of that, and I'm being recorded, so I'm sure someone's going to see this later and tell me I'm wrong. But yes. Any other questions? We're good.
Thank you.
All right, cool. All right, so then we're gonna. So we showed you how to do this. Now let's get a little more interesting here. So I have another set of data I'm going to work with now. Instead of airlines, this is a bigger data set. This is a set of flight delays. So just to show you what this CSV looks like, again, I'll do a real quick preview here and pull this up. This is, yeah, it truncates it, only previews the first 30 megabytes. So this is for each airline, basically for each day of, I believe, 2008 through 2013 or something like that, flights and the average delay. So it's got some cool data. I just pulled it because it's a bigger data set that I can do some simple joins with. But again, this is expressed as a CSV file, and I already have it loaded into HDFS just for simplicity. And no, I don't want to save anything to it. Okay, so we're going to use our airlines data database again. And I need to connect this notebook to the BDC before I run anything so it doesn't error out. There we go. Connected to the airlines data database. So now I'm going to create another external table, just like I did before, for flight delays. So I'm creating that, defining all my data types like I would any other SQL Server table, pointing it to that file, and I won't give you the time waster of working through a data type problem. Again, these should all be correct this time. So if we select from here, we can see the top 100 rows of flight delay data, and you can see here we have year, month, day of the month, departure time, arrival time, scheduled times, the carrier, the flight number, the tail number. There's a whole bunch of data in here. What I'm going to do now is I am going to take this CSV file and copy it into another format called Parquet. Now, Parquet is a more data science-y format, and it's a compressed format. So whereas a CSV file is just a nice, text file that's very easy to read, Parquet is not. Parquet is compressed. It's actually compressed on a per column basis. So it's kind of got some parallels to like a SQL Server column store index, which means you get a smaller file and you get performance benefits. Bigger downside to this is probably the fact that you can't read this file, in a text editor like you can a CSV, but you get great advantages in terms of speed. So what I'm going to do here now is I'm going to create a data frame in Spark again, and just this is going to take another minute or so, unfortunately, to fire up the Spark application in this particular notebook window. And then once that runs, it will spit back the first 10 rows. But then I'm going to run this df.write.parquet command, and I'm going to take the data frame of this flight delays file and write it out to Parquet files. And it's going to go into its own directory called flight delays/Parquet. So it'll be here in HDFS in a different folder next to CSV, and it will be these Parquet files. And it will actually, because I have 2 nodes in my HDFS cluster, there we go, it will actually spit out 2 files, 1 file for each node. It'll kind of split them up between the 2 for speed, and you'll wind up with both of these. And then we'll have the data in a Parquet format that we can query and work with as well. And this should only take a few seconds. So hopefully it doesn't take too long. There we go. Looks like it's done. So now if I refresh flight delays, you'll see I have a second folder here called Parquet, and I have 3 files in it. I have the 2 actual Parquet files, which are named with GUIDs, and then you have a success file, which says that it completed writing them. So now that I have Parquet files, I'm going to go back to our database here, our airline data database, and create a schema called Parquet, because now we have data that we will be accessing from a Parquet file as well. So we'll put that into a Parquet schema. We will define a new file format, which is a Parquet file format, which is a bit simpler than a CSV. I don't have to specify a whole lot other than saying format type is equal to Parquet. And then I'll create an external table called Parquet.flightDelays, which has all the same flight delay data, but it will be querying across those Parquet files. So if you'll notice here in the location part, I'm pointing it not at a file, but at a directory, right? And this is what you do for a lot of analytics type work, is you don't necessarily look at an entire file. You'll point the system to a directory or to a tree of directories and say, hey, scan everything in here. So that's what I'm doing. I'm saying, hey, scan this folder of Parquet files and return that as an external table. If I select the top 100 rows from that now, it'll come back with those pretty darn quickly. And again, this is the same data we looked at before. It's just reading it from a Parquet file instead of a CSV file. Now, the next thing we're going to do is we're going to take this data and we're going to load it into a third location. We're going to load it into the SQL data pool that I talked about. This is that pool that's part of the big data cluster that is multiple SQL servers, and data is spread across those SQL Server instances. And I see a question here that just popped up into the chat room. I'm sorry, it says, can BDCs be run on-prem? Yes, they can. You definitely can run a BDC on-prem. You have to have, virtualization and Kubernetes and whatnot set up, but you can do that. I actually have a lab here at home where I run them on-prem, but for demos like this, I find it actually easier to do it in Azure. But yes, you can run a BDC on premises if you wish. So what I'm going to do now is create this data pool, and we're going to copy this data into the data pool. So what I have here is I'm using my airlines data database. I'm creating a new data source called SQL Data Pool, which points to the SQL Server data pool in our big data cluster. I'm going to create a data pool schema. I'm going to create an external table for the data pool, which again has the same data types and whatnot I've been using to date for this table. But you'll notice here at the bottom, we have with data source equals SQL data pool and with distribution equals round robin. So we're actually doing round robin distribution of data between the nodes in this data pool. Now this data pool has 2 nodes. So it's you can have more than 2. You can have 4 or a whole bunch more nodes in your data pool. I'm just using a 2-node one to kind of show here. But we can create this external table in the data pool. The master instance will then coordinate that with the data pool instances. And now what I'm going to do is just insert my data into the data pool from the CSV file version. And this is just a regular SQL query: insert into data pool.flightDelays, select star from CSV.flightDelays, right? Easy way to copy the data into there. That's exactly what's going on here. So this should take just a couple more seconds. I think it's about 2 million rows for this data set. So we'll see, let this go real quick. There we go. All right, so we copied like 1.9 million rows. If I were to query the data pool and just count how many rows are in the data pool, select count star from data pool.flight delays, that'll come back pretty darn quickly, and we have just as many rows in there as we expected. But one thing you can do with the data pool is, because like I said, it is actually 2 servers that the data is split across in my case, is you can run a query on each of those servers individually to see how many rows are on each of them. So that's what I'm doing here. It is exec use airlines data count, select count from data pool.flight delays, but it has at data source SQL data pool. So what this will do is this will actually query each of the machines in the data pool separately. So now we'll get 2 results because there's 2 machines. And you'll notice we have one has 968,394 and one has 968,364. So data is pretty evenly split. It's probably doing it in some level of batching between them. It's not exactly writing one row to one and one row to the other. It's probably batching them in groups of maybe 32 or something like that. I'm not sure, but roughly even distribution between the members of the data pool. So now we have this flight delay data in a couple different locations, right? We have it in a CSV file, we have it in a Parquet file, we have it in the data pool, and we have all 3 of them. How about some speed comparison very quickly, just to see how long does it actually take to query this? So I'm going to select count star from csv.flight delays, right? Just count all the rows in the CSV file. This will undoubtedly be the slowest part because it actually has to go read through a CSV file, every row, and count the number of rows. And we get our results there in about 7.3 seconds. Now I can do the same thing against the Parquet version, and the Parquet version is of course compressed. So, and there's probably metadata involved in there too. So if I query this one, I get a result in 0.4 seconds, right? A little bit faster, just a tiny bit. And then if I do the same thing on the data pool, that's even faster. That's 0.3 seconds. So we have the same data in these locations being exposed through external tables as part of the big data cluster, and we can access them all this way. But what's really cool about the big data cluster is you can join between these different sets pretty seamlessly, right? So I have a query here where I'm selecting some rows from the Parquet version and joining it to the CSV version. And that shows up quite seamlessly, even though we have 2 different files, 2 different file formats. They're all exposed in a place where you can write a one-stop shop query in T-SQL and access all this data this way. Or if I was more of a Spark person, which I am not at this point, I could write Spark queries as well and see these files in that end. So one more little thing I want to show here. If I go back to my slide deck real quickly, I'll just pop it on the screen here. One thing we talked about before, here we go. This external data at the top, right? I've spent some time, we used the master instance, we were using the compute instance, whether we knew it or not. We used the data pool, we did some brief queries with Spark. Haven't really touched on external data. So this is the final thing I'll show you very quickly. You can mount other external data sources into your big data cluster as well. So what I'm actually going to do here is I have some data that's sitting in, this is actually sitting in an Azure data lake. So it's already in Azure. It's actually from another presentation I do on data lake stuff. But what I have here is parking ticket data from the city of Chicago. And we can actually, and we can even do this graphically, I'll show you here. If we right click on HDFS, we have this option to mount HDFS. You can actually mount other external data sources into your HDFS for the big data cluster and then access them this way. So I'm going to create a path here called parking tickets. You all get to watch me type a tiny bit. You need a remote URI, so where are you going to access this data from? As I said, I happen to have a Azure Data Lake Generation 2 sitting out in Azure already, so it can be accessed at this location. So that's what I'm going to point the big data cluster to. And then, hang on here, I need my credentials so I can actually access this because it's not open to the world. So, and you don't get to see the credentials, it'll fill them in like this. But if I do this and hit OK, it should hopefully connect us to there. You can see where I did this earlier today as I was setting this all up. There we go. If I refresh HDFS now, I have another folder here called parking tickets, and I have CSV files of parking tickets from the city of Chicago from 2003. And I have, folders, and we can just preview one to show you what it looks like, but it is literally just a list of all the people who received parking tickets in Chicago on this date and what happened with them. So I have external data as well that I've mounted into my HDFS store that I can also query either via external tables if I were to create those or utilizing Spark. So this is this is all the demo material I have, unless we have other questions, but this is just kind of a brief introduction into what can you actually do with a big data cluster and what makes it so neat. And what makes it neat is you have the ability to have this data from all these disparate sources that you can combine and work with in one place and kind of have that single pane of glass queryability to it. So if there's any other questions, I guess we can circle around to those really quickly once I show you my final 2 slides here. If you'd like to learn more about what I just talked about, I have some resources here. And again, this is all up on GitHub, so you can get this information here too. Microsoft has a really good workshop on big data clusters architecture that's actually on GitHub itself. You can access that. If you're looking for information on Kubernetes, Klaus and Anthony Nocentino have some great blog posts on working with Kubernetes. Mohammed Darab is also a wonderful resource on big data clusters in general. He's done a lot of work with it. Ben Weissman has a great course on Pluralsight, if you're a Pluralsight member, on building and working with big data clusters. And you can get all the materials from this session, again, at my website, or you can get it on the user group website as well. They're going to put it up there as well. So if you go to bobpusateri.com/r/ABCs of BDCs, it will take you to my GitHub, where again, you can get all this material. So at this point, if we have any other questions, I'll be happy to answer whatever I can. If you're looking for my contact information, or again, where to get the materials from, it's highlighted there at the bottom of the screen.